I'm Bob Dunsmore. I've come to Australia from the United States, if you know where that is. And you'll have to excuse my English, but I'm here with my friend Leona. This is her house. She invited me to Australia to build a do it yourself heating system that uses the sun. Hey, come here. Yeah. I mean, she's made this possible. She's been working on it for years.
4 years.
4 years. And what we're trying to do is bring something that has happened in the United States, which is a do-it-yourself movement that started in Colorado where I was living. And we built thousands of these, mostly in workshop situations. And I want to say that every collector we've built has been unique because every house is different. How much energy you need to blow into the house to heat the house is different. And we have had some obstacles because of a cyclone that happened here in Brisbane. And so my flight was canceled. She couldn't get out of Queensland. So
Judy picked him up at the airport.
we're,
That's been a community thing.
we're kind of running on what
Judy?
we've been able to obtain. Yeah, come on in, Judy. I mean, so many people have helped with this. It's amazing. Look, anyway, you'll be able to show. Oh, I'm sorry. You'll be able to show the tools in that van. Thanks, Sean. He brought all the tools, and he's got a lot of engineering skills. So I'll say goodbye for now. Turn it over to you.
Oh, I'm just here to help.
Well, I know. Where the first thing we're going to do, you might want to show, is plywood. We're going to cut the plywood, which has been scored right here, where we're going to cut it with that skill saw or circular blade. We're going to cut this. This is a dimension in here of the glass. So the entire collector is designed around the size of the glass that would allow the solar energy to penetrate and hit an absorber plate. So the first thing we'll do is cut this dimension, which is a dimension of the glass, and then we'll build up the collector box, and we'll be putting the collector on the north wall of the house vertically. I want to explain to you a little bit of the schemata of what we're doing, which can vary quite a bit. In fact, in the old days, we used to make, maybe you can show this here, we used to make collectors out of wood. And then they started to smoke and char with the heat. So instead of using wood, we now use what we call C-channel, which is bent in a sheet metal shop as a C, going all the way down to here, a big C. So that'll be the perimeter of the collector right there. And then here's a plywood, so it's going to actually go behind the plywood to keep moisture from coming in. And that's all going to be on the vertical on a wall. So what we're going to work on next is this step over here, where we're going to put two holes into the collector. One will be for the hot air going right to the blower. And so the blower is going to suck air through the collector, and that'll help clamp down all the interior parts of it. See, if you were blowing that in, it could blow the collector apart, basically. But we're going to be sucking all that down where it's all silicone caulked. And so be sure when you put your blower in that it's pulling air through the collector. Okay, and so Sean is going to show us how we measured for the hot and cold. The hot line is going to go through a vent already in the crawl space under the floor of the house. The blower will push air, and I think it might be good to show the pipe over here lying down in the grass over there. It's going to push the air all the way to the south end of the house, because the south end of the house is where it's coldest. And it's going to push it into the garage right there. That's the south end of the house, where we took off the insulation from the garage to allow it to heat the floor. And we have found out that when you blow hot air under a floor, the heat stratifies, the hot air stratifies under the floor and turns the floor into a radiant heat source. So Leona's going to be able to go barefoot this winter, or she'll get her money back. This is for free. I'm not charging anything. And so Sean will show how we did the measurements for the inlet and outlet to the collector. And how much did you give a little extra so the pipe would fit through easily?
3 millimeters or 1/8 of an inch.
Okay.
This is just standard 6-inch or 150 millimeter galvanized steel spiral wound pipe, but you could use seam weld or whatever you got. These are joiners. They're also nominally 150 millimeters or 6 inches. The joiners are male. They slot inside the pipe and they have an actual dimension of 148 millimeters. The pipe has got an actual OD of 153. We're going to cut the circles here. I've just drawn a line around them roughly, and then we're going to use whatever you've got. You could use a jigsaw, you could use a hole saw. We're going to use a router today because that's what we've got. And cut the hole slightly bigger. We're going to stick the male joiner in there, and then we're going to stick the pipe over that.
And did you use to make these lines?
Yeah, just use a sliding square, whatever tools you got. We've set that in 5 inches or 125 millimeters from both sides, and then just draw a circle there so that they match up roughly.
So this will be the hot air close to the electric line. It's important to get the blower connected into electric line, and so the hot air should be closer to the blower as possible. And this will be the cool air return over here. And I think we're ready to roll. Oh, and I've got some good news.
Yes.
The sun's out.
Well, that is good.
What did you just do?
I just tidied it up a little bit.
I want to show the importance of a vertical collector on the wall if you do not want the summer sun to heat it. Now, if the collector were on a roof, let's say one thing we've learned to do is to heat water with the summer sun. By blowing air around a water tank with fins on it, and then insulation around that, so that you can actually heat water with hot air, and then return that from the water back to the collector in the summer. Well, the system we're doing is not to heat water at all. It is to heat the house. And you don't want, in the summer when the sun is high, you don't want the collector to turn on. And so what we call a real low angle of incidence, that low angle of incidence bounces the sun right off, and it does not heat up the collector. But when you get the sun in the wintertime dropping towards the horizon, here in Wentworth Falls, the lowest point on the winter solstice, the sun is 34 degrees from, this is a 34-degree angle right here, okay? And therefore, the sun's rays penetrate into the collector. All the rays from the sun are parallel, by the way. They all enter into the collector, heating it up in the winter. So the colder it is here, the more hot air you'll get. So it's the way it all works out. And then as the sun comes back up, it turns on less until you don't need heat in the summer. And so we're going to go ahead now, and let's move to this chart over here again. We're going to go ahead and put in the C channel, this big C, behind the plywood. So that'll be our first step to building the box for the collector. These collectors could actually catch on fire in the old days, back in the 1970s when we started building them, because we made them out of wood. And it got so hot in there that they started smoking. And so we've gone to C channel, which is what this is. You can kind of see you can see the C, right? And so this will go like this. You see how that when we turn the collector over, we'll have the perimeter of the box. And so one thing we don't want to do is have two pieces meet at the corner because it'll leak. And so we're going to actually bend this and have a solid piece of metal there. And that's a little tricky, but it looks like Sean knows what to do. So let's watch him cut out a notch to be able to bend it. That's a 90-degree angle.
And then it just bends.
Yeah,
Very good.
you know, without having an opening there at the corner because it could leak.
Yeah.
And we want this airtight.
Yeah.
And so, yeah, we just all we have to do, I hope, is we'll see how this works. These are self-tapping screws so that they tap right into the metal.
Yeah, I'm just chopping up linear just to sort of.
These they can be a little farther apart. That section there that overlaps right here and over there, those two sections. So now we're ready to pop rivet this up into there, tighten it up. And you can see how the very little possibility of air escaping from the collector. We don't want any dust getting in there.
There's someone here, or that we want that.
Yeah, just so it misses plywood, I guess. The reason why we like pop riveting is that it's a nice smooth, it's not like a screw. It goes right up in close and makes it real airtight connection. And we'll do that on these two scabs, these two parts here. We're going to flip this collector over and work on the inside of it now. This is the back side that'll go against the wall. So we're going to take this crimping out, which helped us to put the two parts in the overlap position. We'll take that out now and smooth that out because the glass is eventually going to go right on top of here. This ductboard insulation will be inside the collector, and the air is actually going to move right over this surface. And just to be extra cautious, we're going to put silicone caulks with using spatulas or whatever to smear a real thin layer over this fiberglass actually, so that it won't move into the airstream. We've opened up collectors 40 years after using that, and it works just fine. So silicone, the side of the that faces the air chamber. I want to point out that we used to do it this way. We used to use this side, thinking that was a great place for the air to move. And after a few years, we found little flecks of aluminum in the airspace. So we don't do it that way anymore. We do it this way. And the silicone, which will be smeared here in a moment, will take care of the problem of fibers in the airspace. Okay, now this is the inside of the air channel right here.
we have that silicone caulk over the fiberglass so that the fiberglass doesn't get into the airstream.
We are going to put in now the what we call a C-channel support for the black absorber plate that absorb the sun's energy. We'll be taking a look at putting that in just a second, but right now we're putting in the supports for it. And so it's a C-channel, as you can see right here, running all the way around, and the absorber plate will sit right on top of that, and we'll screw that down to it. And he's putting in the last piece of that perimeter C-channel for the absorber plate, right over our insulation. So we've he's notched that out so it'll fit a little bit better right into this lip here that it holds up the absorber plate. And then I wanted to point out the holes that were made with a box cutter, right? Box cutter tool, just right through the insulation and to the cold air return to the collector. And this will be the hot air outlet on this side, also cut right through the insulation. We are preparing to put the pipe into the airspace of the collector. And so we're cutting tabs. Can you see that? The tabs being cut. And can you just briefly demonstrate how we'll put it in there and then you see, then we'll fold these tabs down and screw it, right? In fact, it'd be good to caulk in here and underneath before all this area before we bend these down, because that way we'll be sure to get the air to go right in there and not leak out through here.
What's going to happen is that air will be pulled in through the cold air elbow that goes down to ground level. Cool air will come in. It'll be split real nicely by this baffle, which I love. And it'll curve around and then come into the suction side of the squirrel cage fan. So on top of this C-channel here, which we call the absorber support, will be the absorber plate, and that'll be sealed with caulk so that this air space will be absolutely hermetically sealed against the front of the absorber plate and the glass.
Okay, that's good. And then we're going to paint this a flat black to absorb the sun. And this is going to be down in this level right here. And then on top of here will be the glass. And the sun will be able to come through into a dead air space to heat this when we paint it black. And that'll be the greenhouse effect right there. We are going to use denatured alcohol. If you put this onto the this absorber plate, before you paint it, it will get rid of the oils and help make the paint stick better to the plate, and it won't peel off while over many years of use. We've opened up collectors 40 years after building them, and they've been perfect. So no worries there, mate.
Very good.
And then now we're going to be trimming this absorber plate right along here to fit perfectly on that little lip. Maybe here you can see the lip right here that we'll be putting it on, and we'll screw that down and have a nice absorber plate before we put the glass on. Of course, we have to paint this first, right? And so I'm putting in the last screw here in the absorber plate, and it's going right into that C channel underneath here. There we go. So we're done. All of these screws are holding down that absorber plate, and now we're going to go ahead and spray paint all of this with a real fine layer of paint from a spray can. You don't want to put that on too thick, or it will actually block the transfer of heat to the metal. We're going to now spray the absorber plate with a real fine layer of high temperature flat black paint. So you see it's up good to 1,000 degrees Fahrenheit or 540 centigrade, and that's going to be wonderful for this collector. Just a real fine layer. We put masking tape all around the edges here where we're going to put the glass.
So when you're attaching the glass onto the metal frame, there's all different types of silicon, sealants, and such things. Sikaflex makes a whole range of products. They've usually got a 3-number designator like 117, 269, or all the rest. Get online, find out the appropriate one. You'd want something for attaching metal to glass.
We're going to silicone now the top perimeter C-channel, and then lay the glass down right onto that silicone and let it harden overnight. So I'll go ahead and start putting the silicone down for the glass. There's the finished product. We've got the glass down on a bead of black caulk here. And I'm going to clean off a few little smudge marks that we've got. There
Oh my goodness, it looks great.
Hi, Leona.
Hi. Boy, it's a wonderful job.
It is beautiful.
Do you think maybe we could put a frame, a little bit around it to frame it? It's just beautiful enough to frame.
To protect the glass would be a really good idea.
Okay.
Yeah,
Okay.
to put an angled frame
Okay.
all the way around. That
Okay.
would be good.
And it will be this silvery color or black color or what?
I think that it would match this the perimeter color. You say this is available at Bunnings, and it's 1.5 mil galvanized.
Yeah, it's galvanized. 30 millimeter, 30 millimeter.
Now we have the frame on the collector, and it will protect the glass and also look a lot better because underneath here is all that goopy silicone caulk. It didn't look all that great, but now the collector looks great, I think. There we go. What I call the DownUnder collector.